Hello, in this video we're going to do the Unit 4 free response question part B, problem number 1. So you see we get this equation. It's a piecewise function for the depth of the river, where the depth is measured in feet and t is measured in time. It's got two parts, from 0 to 6 and from 6 to 10. So for part A of the problem, asks us to find derivative of w at 8, w prime of 8, and then explain it using correct units. So make sure you don't forget to do this part. A lot of questions will ask something like that. So I know I'm going to find w prime of 8, so I should use the piecewise function that involves 8, which is from 6 to 10. So at t equals 8, w equals, or w of t equals 10 minus 1/5 t minus 6 squared. So w prime of t is going to equal, the 10 is going to go away, and we've got 2, I'm going to bring the exponent down in front, so negative 2/5 times t minus 6 to the first. Then I'd look for chain rule, but the derivative of the inside is just 1, so that's my derivative there. And then w prime of 8 would be our negative 2/5 times 8 minus 6 is 2, so we'd have negative 4/5. If you stop here, you're not going to earn all the points because we didn't explain it in context. So this function w is the depth of the river, so the derivative is the rate of change of the depth. So the rate of change of the depth of the river is negative 4/5, and we have our rate of change would be in feet per hour. Okay. An alternative way to say this would be the depth of the river is decreasing at 4/5 per hour. Notice in this one, the word decreasing carries the weight of the negative. That's what that tells you, it's negative. So you would not repeat the negative there. And in fact, you'd probably lose points if you did that. All right, part B now says, it tells us a fact. W is concave down from t equals 3 to 3.5. And it says to use a tangent line to W at t equals 3 to show w of 3.5 is less than or equal to 9. Okay, there's a lot going on in this, and it's the first time you read this, you're like, what am I supposed to do? Okay, so break it down into smaller pieces. All right, so it says use a tangent line. Well, we know how to find a tangent line. Okay, and it tells us where. For a tangent line, we need a slope and a point. All right, so we're thinking slope is going to come from w prime of 3, and point is going to be 3 comma w of 3. So w prime of 3 would come from the derivative of the top. So w prime of t, the top piece of the function, is that 17/2 minus da da da. So let's see, the derivative of cosine is negative sine, so it's going to be positive 3/2 sine of pi t over 6. Chain rule says I then need to multiply by the derivative of the inside, pi over 6. So w prime of 3 would be 3/2 sine of 3 pi over 6, which is just pi over 2, times pi over 6. But sine of pi over 2 is 1, so I'm going to get that this equals 3/2 times pi over 6, which would be 3 pi over 12, which is pi over 4. All right, so I have my slope, and to get my point, I just need to plug in w of 3. If I do that, again, that's from the top function, so that's going to be 17/2 W of 3 is 17 halves minus 3 halves cosine pi over 6 times 3, and I have 17 halves minus 3 halves times, that's pi over 2, cosine of pi over 2 is 0. So we get equal 17 halves. So now I know my point is 3 comma 17 halves. Point and slope, okay. So I have those, I'm running low on room here. I can write my tangent line. Again, if we're not quite sure what to do, we're breaking it down into the parts that we can do first. All right, so I couldn't use just y minus y1, so y minus 17 halves equals my slope, pi over 4 times x minus 3. Okay, so that's our tangent line. And to help us answer this question, let's think about graphically what this is, what this looks like. So we're kind of dealing with this section of the graph that goes from 3 to 3.5. And I know at 3, I'm going through the point, this is the point 3 comma 17 halves. And I know my tangent line, which I'm going to draw in red, is a slope of pi over 4. That's a positive slope, so I'm going to draw a positive slope. Now the actual graph, we're told, is concave down from that point to 3.5. And so the actual graph must be doing something like that if it's concave down. So it's going to be underneath, which means my tangent line approximation should be an overestimate. So let's use this tangent line to approximate W of 3.5, and we'll know that that value is bigger than the actual W of 3.5. So using my tangent line equation here, I'm going to go W of 3.5 is approximately, I'm going to add the 17 halves plus pi over 4 times 3.5 minus 3. Well, that's approximately 17 halves plus pi over 4 times a half, which would be pi over 8. So now this last part uses a little number sense here. So we already know that my estimate here, W of 3.5 approximation, is an overestimate. So I know the actual W of 3.5 must be less than 17 over 2 plus pi over 8. And you should justify this by saying because W is concave down over 3 to 3.5, the approximation is an overestimate. So then it's just a little bit of a numbers game here. So pi over 2, or 17 halves plus pi over 8, and I'm trying to show that this is less than something that is equal to 9. I'm trying to show that this is less than 9. Well, if I'm thinking about 17 over 2, that's 8.5. So I really just need one more half. So let's see if this is a true statement. 17 over 2 plus 1/2. That does equal 9, right? Is it true that 17 over 2 plus pi over 8 is less than 17 over 2 plus 1/2? It is true, and here's how we know. Because if you think about 1/2, that's really 4 over 8. And pi over 8 would be 3.14 over 8 approximately, which is less. And so we know that this is a true statement here. So we've shown that our actual value of W 3.5 is less than 9. All right, finally the third part. Let's zoom in here. Finding the limit as t approaches 2 of W of t minus t cubed plus 1/4 over t minus 2. So we've got to evaluate this limit, and first we know t is approaching 2, so we're supposed to use the function w as t approaches 2, and if we go back, that would mean we're using the top part of the function. So I'm going to plug in there and see if that helps at all. So we've got the limit as t approaches 2 of 17 over 2 minus 3 halves cosine of pi over 6t minus t cubed plus 1/4 all over t minus 2. Well, anytime we're evaluating a limit, you're supposed to plug in first. So let's see what happens if I plug in t equals 2. So at t equals 2, I would get 17 halves minus 3 over 2 cosine 2 pi over 6, which is pi over 3, minus t cubed is 8, 2 cubed is 8, plus 1/4 over 0, okay? And if we worked out all that on the top, we would get 0 over 0. All right, so this limit evaluates to 0 over 0, which is indeterminate. And we just learned a nice new way to deal with an indeterminate form of a limit, and that is called L'Hopital's rule. So we are going to know that this limit is going to be equal to the limit of the derivative of the top over the derivative of the bottom. Okay, so the limit is going to equal the limit as t approaches 2 of the derivative of the top. Well, I know the 17 halves and the 1/4, those are going to become 0, and I'm going to get derivative of cosine is sine. We've already done this derivative, haven't we? So we've got positive 3 halves sine of pi over 6t times pi over 6 for chain rule, and then minus 3t squared, and the derivative of the bottom is just going to be 1. And so at this point, I won't get 0 over 0 anymore. So let's plug in 2 on the top, and when we do that, we will get 3 halves times sine of, plug in 2, I get pi over 3, times still pi over 6, minus 3 times t squared, so t squared is 4, all of that over 1. So that's 3 halves. Sine of pi over 3 is root 3 over 2. And I still have the times pi over 6 minus 12. And that's going to give me, let's see, I get 3 pi root 3 over 24 minus 12, which would be pi root 3 over 8 minus 12. And that is our answer to that limit. All right, thank you for watching.